Okay, let's get the show going. Sections 4.7, 5.4 review. And let's start with the following. This is 4.7, Graphing Inequalities. Here we're graphing y greater than negative 1/2 x plus 1. To graph this solution, we graph the boundary line, and if it's greater than, we use a dashed line. If it's greater than or equal to, we'd use a solid line. So we start out by graphing the boundary line. So our boundary line is y equal negative 1/2 x plus 1. It's just a line. It's in slope-intercept form. So we have 0, 1. We could use the slope, go down 1 over 2 and get 2, 0. Or plug x equal 2 in and we get negative 1 plus 1 is 0. And then one more point would be 4, negative 1, which we could also find by going down 1 over 2 using the slope. So that's our boundary line, but we use a dashed line because the boundary line itself is not part of the solution. Now we have to shade one side of that line, and to do that we pick a test point. I'm going to pick the test point 0, 0. The test point can be any point that's not on the boundary line. 0, 0 is usually easy to evaluate. We plug in 0 for y, 0 for x, and we get 0 greater than negative 1/2 times 0 plus 1. Well, that results in 0 greater than 1, which is false. So that means we do not shade the side that contains 0, 0. We shade the other side, the top side. If it had been true, we would have shaded the bottom side that contained that point. So that's our graph. It's the shaded area to the top of our dashed boundary line. And we're going to jump right over to section 5.4 because that's going to give us the 4.7 problems anyway, where we graph inequalities. We're going to graph the solution to this system of inequalities. Now to do that, we graph each inequality. The solution will be the common shaded area. So we just graph each of these inequalities like we did in the previous problem. Graph the boundary line. In this case, use solid lines for both since it's less than or equal to, greater than or equal to. Shade the side by using a test value, and that common shaded area will be our solution. So pause the tape and at least start by graphing the boundary lines for each of these two inequalities. Graph the related equation, use a solid line for both. So for each of these lines, the easy points are the intercepts. For the top boundary line, we have the intercepts 3, 0, 0, 2. So that's my line sloping that way in green. And then for my bottom boundary line, 2x minus y equal 4, we have the intercepts 2, 0, and 0, negative 4. So it's important you get the boundary line correct in order to do these. Now, figure out which side of these lines to shade. So pause the tape and do that. Okay, so I'm going to pick that 0, 0 point for both of these. When I plug 0, 0 into the top inequality, I get 2 times 0 plus 3 times 0 less than or equal to 6. That's true because you get 0 less than or equal to 6. So that means for this graph in green, I shade to the bottom, the side that contains 0, 0. Now, for 2x minus y greater than or equal to 4, I plug 0, 0 into that one, and I get 2 times 0 minus 0 greater than or equal to 4. Well, that's 0 greater than or equal to 4, which is false. That means I don't shade the side that contains 0, 0 for that one. I shade the other side, the bottom side. So now I look, where do these shaded parts intersect? And it's this bottom corner. Everything in this bottom corner, that's our solution, the common shaded area. Okay, for our next problem, we're going to graph the solution to 2x minus 4y greater than 8, 2x minus 4y less than negative 4. So we're going to plot both of these inequalities and see where the common shaded area is. So you're going to have two boundary lines. You're going to have 2x minus 4y equals 8 as one boundary line, and 2x minus 4y equals negative 4 as my other boundary line. And you're going to use dashed lines this time because it's strictly greater than, strictly less than. So why don't you try and plot the boundary lines, figure out which side to shade those sides, and see what the solution to this is. So here, once again, plotting the boundary lines, we find the easiest points to find are the intercepts. For 2x minus 4y equal 8, we get the intercepts 4, 0, and 0, negative 2. For our second inequality, the boundary line has intercepts negative 2, 0, and 0, positive 1. Because positive 1 times negative 4 gives you the negative 4. Okay, so we have our boundary lines and we plot them. Then we have to figure out which side to shade. So now our top inequality, if we plug in that 0.00, because it doesn't lie on the boundary line, we can use that. We get 0 greater than 8. That's false. So we shade the side that does not contain 0, 0, which would be the bottom. For our second inequality, plugging in 0, 0, we get 0 less than negative 4. That's false also. So we shade the top part of that, the side that does not contain 0, 0. So 0, 0 is all alone. There's nothing there. And these two regions don't seem to intersect. And if you take a good close look, the top inequality has a slope of up 2 over 4, which is 2/4 or a half. The other one has a slope of up 1 over 2, a half. They have the same slopes. And so they never intersect. These areas will never intersect with each other. So for this case, there is no solution. Okay, for our next problem, we're finding the solution to this inequality that has three inequalities. 2x plus 2y greater than or equal to 4, 2x minus 2y greater than or equal to 2, and also x less than or equal to 6. That's everything to the left of the vertical line x equals 6, including that vertical line x equals 6. So you have three inequalities, you shade them, and then we're going to find the area or the shaded area that's common to all three. So pause the tape, see if you can get this solution. So our boundary line for our first inequality, 2x plus 2y equals 4, has intercepts 2, 0 and 0, 2. So 2, 0 and then 0, 2. It's a solid line. Then our second inequality, the boundary line, 2x minus 2y equal 2, intercepts 1, 0 and 0, negative 1. So 1, 0, 0, negative 1. And then for x less than or equal to 6, the boundary line for that is just the vertical line, x equals 6. So we have a solid line at x equals 6. A solid vertical line, that is. Now we have to shade these three. So for our 2x plus 2y greater than or equal to 4, when we plug 0, 0 in, this point at the origin, we get 0 greater than or equal to 4, which is false. So we shade the other side. The side that does not contain 0, 0. For 2x minus 2y greater than or equal to 2, when we plug 0, 0 in there, we get 0 minus 0 greater than or equal to 2. That's false. So we shade the side that does not contain 0, 0, which is the bottom. But then we also have the inequality x less than or equal to 6. Well, every single point to the left of that vertical line is going to have an x-coordinate that's less than 6. So we shade to the left of that vertical line. That's the solution for that special inequality. And we see that all three inequalities overlap in this triangle. So this triangle that we get, that's our solution. And I've included a review problem here, similar to one of your homework problems. Find the equation of the line passing through 1, negative 1, and 4, 6. So those are the 2 points, right in slope-intercept form. Now, if you remember, you need 2 things to find the equation of a line. You need, number 1, m, which is y2 minus y1 over x2 minus x1. And you need a point, x1, y1. Well, we have a point. We have 2 points. You can choose either one as x1, y1. And then you're going to get the equation as m times x minus x1 equals y minus y1. So find the slope, plug the slope and one of the points into that what's called the point slope form, then rewrite your answer so it's in this slope intercept form of y equals mx plus b. As you remember, that's the slope intercept form. Basically solve the equation you get for y. So try this on your own. Get your slope, get your equation, rewrite it, and then we'll go through this. So you should get a slope of 7/3, and then plugging that into the slope, point slope form, 7/3 times x minus 1 equals y minus a negative 1. Now you rewrite that. So if you don't have that, fix it up, and then try and rewrite that and solve for y and get it in the slope intercept form. So pause the tape and try that. So we start by distributing the 7/3 times x, 7/3 times negative 1. And on the right side, I'm going to change y minus a negative 1 to y plus 1. Then you subtract 1 from both sides. But in order to subtract 1 from negative 7/3, you have to write it as minus 3/3. You need a common denominator. So you get y equals 7/3 x minus 10/3. And we know it's correct if we plug in 1. 7/3 minus 10/3 is negative 3/3, negative 1. Also, for the second point, and it should work for both, when x is 4, we get 28/3 minus 10/3 is 18/3, which is 6. So it checks out for both points. We know it's the correct answer. And that's it for this review video.